Welcome back, Geometry Champs. If you have been following along, you are already on your way to mastering triangle congruence. But if you missed part 1 or part 2, hit pause and check them out first. Links are in the description. Before we jump in, challenge yourself. Take the quick quiz linked below to test your understanding of congruent triangles. Then come back and let's put your skills to work. Grab your notebooks and pencils because today we are diving into some exciting congruency problems. Let's solve like a pro. Let's start with the first question. By which facts are the given pairs of triangles congruent? Please have a look over first two triangles. Can you tell me by which axiom these triangles are congruent? Very good. First thing you should have noticed is these two triangles are right-angled triangles. So we have to test RHS axiom first. In RHS axiom, R, right angle, comes first. So both the triangles, their right angle means R is valid. Now comes H means hypotenuse. The hypotenuse are AC and PR. They are also equal. And finally comes a pair of corresponding sides. BC and QR, they both are equal. Means these two triangles are congruent by RHS axiom. Have a look over the second question. By which axiom these two triangles are congruent? First, a pair of angles are equal. Then a pair of sides are also equal. And finally, another angles are also equal. Means they are congruent by ASA axiom. Here, S is enclosed by the two equal angles. Means this is true. Can you tell me by which axioms the triangles in C number are congruent? Very good. All three pairs of corresponding sides are equal. Means they are congruent by side, side, side axiom. Can you please tell me by which axiom the triangles in D number are congruent? Great. They are congruent by side angle side axiom. These sides are equal and then the angle, finally, other pair of sides. So they are congruent by side, angle, side axiom. Let's do the second question. If the given triangles are a pair of congruent triangles, find the value of x and y. Here in this question, we are not supposed to prove these two triangles congruent. It is already mentioned that the triangles are congruent. Since triangle ABC is congruent to triangle PQR, their corresponding sides and corresponding angles are equal. In the first step, can you tell me the side corresponding to AC? Very good. AC is corresponding to PR, so AC equals to PR. Here, the length of AC is 3x minus 1 and PR is 2x plus 3, so they should be equal. We have got an equation. Let's solve it. For that, let's collect the like terms together. Means 3x and 2x, I'll keep them on the left side, and plus 3 and minus 1, I keep them on the right side. Here, 3x minus 2x is x, and 3 plus 1 is 4. I got my answer for x. Let's find the value of y. For that, can you tell me the side corresponding to BC? Very good. BC is corresponding to QR, so they are equal. Let's replace the values of BC and QR. BC is y plus 5 and QR is 2i minus 1. If I collect the like terms together, 2i goes to the left side and becomes minus 2i, and plus 5 becomes minus 5 when it is sent to the right side. Here, y minus 2i is negative y, and minus 5 minus 1 is minus 6. If I multiply both sides with minus 1, then I will get y equals to 6. Therefore, my final answer is x equals 4 and y equals 6. Let's jump into the third question. Observe the figure alongside and show that triangle AOB is congruent to triangle COD. Also prove that AV equals CD. First, we will prove triangle AOB is congruent to triangle COD, and then we move to AV equals CD. Let's start our solution. Given in the figure, AO equals CO and angle BAO equals angle DCO equals 90 degrees. These are the given information. We have to prove triangle AOB is congruent to triangle COD, and finally AB equals to CD. We have to prove this. Let's start our proof. We make a table with two columns, statements and reasons. In the statement sections, we write our statement, and in the reason sections, we write the reason behind that statement. Okay, let's try to relate our axiom with these two triangles. Here we are given these two angles equal, and then a side, and finally, I don't think right angle is possible because hypotenuse are not equal. But one fact we can write is these two angles equal, right? Can you tell me the reason behind these two triangles being equal? Very good. They are vertically opposite angles. Let's write same thing in mathematical way. First, in triangle AOB and triangle COD, we know BAO equals DCO. They are angles and the reason is given. Second, we know AO equals CO. They are sides, and again the reason is given. They are already given in the question. Finally, angle AOB equals to angle COD, and the reason is they are vertically opposite angles. See? First we wrote angle, then side, then angle. Means triangles are congruent by angle side angle axiom. If the triangles are congruent, then their corresponding sides must be equal. Here, can I say AB and CD are corresponding sides of these two congruent triangles? Because they are opposite to these equal angles. So, AB equals CD because they are the corresponding sides of congruent triangles. We completed the proof. Let's jump into the fourth question. Observe the figure alongside and show that triangle AOB is congruent to triangle COD. Also prove that AB equals CD. Here, both the triangles are overlapped, so we have to be careful while dealing with these questions. Let's write the given information. In the figure, BO equals DO, it is mentioned that BO equals DO, and angle ABO means this angle is equals to angle CDO. Let's write what we need to prove. We have to prove triangle AOB is congruent to triangle COD, and afterwards AB equals CD. Proof. Following the same technique, we make a table with two columns, statements and reasons. First, we have to write the triangles to be proved congruent, triangle AOB and triangle COD. And let's find the logics. If it is difficult for you to figure out the overlap region, this region is overlapped. Let's take out triangle AOB and COD and deal with them separately. Now it will be easier for you to understand. In triangle AOV, here is point D. In fact, here was point D, which I didn't write here. So you can show them congruent now. See, one angle equal, then a side equal. Finally, if we can show the angle equal, then it will be angle side angle. I think we can show them. See, angle O and angle O. Can you tell me what could be the possible reason for these two angles to be equal? I know you are confused. See, this angle O is the same angle for both triangles. If you see this upper figure, you can easily understand. O is common for both the triangles. So these two angles are the same. So they are equal. Let's write it. First, angle ABO equals angle CDO. It is given. Second, BO equals DO. It is also given and it's a pair of equal sides. Finally, angle AOV equals angle COD. They are angles and the reason is common angles. Means both the angles represent same part. If so, the triangles are congruent by angle side angle axiom. If these two triangles are congruent, are on the sides AB and CD the corresponding sides of congruent triangle? Yes. So they are equal because they are corresponding sides of congruent triangles. This completes the proof. Let's jump into our final question. In the adjoining figure, angle APQ equals angle AQP and angle ABP equals angle ACQ. These two angles are also mentioned equal. If so, prove that triangle ABP is congruent to triangle AQC. Let me shade these two triangles. So we have to show these two triangles congruent, right? Along with this, we have to prove AB equals to AC. Let's ignore the last part and try to prove the first one. Once we prove two triangles congruent, then we can easily prove the corresponding sides equal. Okay, let's write the given information. In our adjoining figure, angle APQ equals angle AQP and angle APV equals angle ACQ. Also, BP equals to QC. This is also mentioned here in the figure. To prove triangle ABP is congruent to triangle AQC and AB equals to AC. Proof. A table with two columns, statements and reasons. Let's brainstorm and try to find out our axiom. This angle and this angle are equal angle. This side and this side are equal side. Finally, if we can show these two angles equal, then it will be angle side angle axiom. Let's try to show them equal, okay? This is 70 degree and let's say this is angle X and this one is angle Y. This one is angle Y. So, you know, X and 70 degree, they are linear pair. So if I add them, I'll get 180 degree, right? Because it will be the sum of linear pair. So if I solve further, this 70 degree will be subtracted from 180. So I'll get X equals to 110 degree. Do I get the value of Y 110 if I follow the same process? Of course, yes. Because 70 plus Y gives you 180 degree because they are again linear pair. Y equals 180 degree minus 70 degree means Y equals to 110 degree. This proves that if two angles are equal, then their linear pairs are also equal. So we discovered the new fact. See, these two angles were equal, and the linear pair of these two angles were x and y, and we found them equal. Means these two angles are also equal. So, angle, side, angle axiom. Okay, first fact, in these two triangles, ABP equals ACQ. The reason is given information, it is mentioned in the question or it is mentioned in the figure. Second, BP equals QC, it is also given. Third, we just proved that APB equals to AQC, they are equal, and the reason is linear pair of equal angles. Boom. Triangle APB is congruent to triangle AQC by ASA axiom. If so, can I write AB equals AC? Of course, yes, because they are corresponding sides of congruent triangles. We completed our proof. Awesome job, geometry champs. Today we mastered using triangle congruence rules to prove triangles are identical. But don't stop here. Keep sharpening your skills. Download the practice worksheet from the description and put your knowledge to the test. And guess what? Next up, we are diving into the fantastic world of similar triangles. You won't want to miss it. So hit that subscribe button and stay tuned. See you in the next video.